Hi, question number 8. The parametric equations of the curve are x is equal to tan square 2t, y is equal to cos 2t for 0 less than t less than quarter pi. Part A shows that dy by dx is equal to negative half cos cube 2t. Part B, hence find the equation of the normal to the curve at the point where t is equal to 1/8 pi. Give your answer in the form y is equal to mx plus c. Now to find dy by dx, we're going to differentiate these equations parametrically. So I can find dx over dt. So differentiating tan, we get sec squared 2t. And there's a 2 here, so we differentiate the cos of 2 times then 2 tan of 2t sec square 2t. So that means we have then 4 tan of 2t sec squared 2t, and differentiating y, I get dy over dt is equal to differentiating cos, I get negative, and there's a 2 here, so 2 sine of 2t. Now, of course, dy by dx is equal to dy, sorry about that, so dy by dt times dt over dx. So if we do this, we're going to get dy by dt, which we have over here as minus 2, okay, sine of 2t times dt over dx. So all of this over 1 over all of that. So that's going to be 1 divided by 4 tan of 2t, and then sec square 2t. So basically what I have, the 2 can go here. So I'm going to get dy by dx negative half, then 1 over tan 2t is basically times cos 2t over sine of 2t. Now we must remember there's a sine of 2t over here, so let me just put it here. So times the sine of 2t multiplied by, now sec, 1 over sec is cos, but there's a square here, so that becomes then cos square 2t. So the sine 2t and sine 2t can go out, and I'm going to be left with dy by dx is equal to negative half cos 2t times cos squared 2t is cos cube 2t. And so that has been shown. So here we are. Part A of the question is done. Now for the equation of the normal at the point where t is equal to 1 over 8 times pi, so we can try and find dy by dx first of all. So what is dy by dx? It was found that dy by dx was negative half cos cube of 2 times t. So 2 times 1 over 8 is pi over 4. Of course, times pi. And of course, if you were to do this on your calculator, you'll be able to get negative root of 2 over 8. Therefore, gradient of normal, okay, we're going to be using m1 times m2 is equal to negative 1. So that's going to be then negative 1 divided by negative root of 2 over 8. And just plug this in your calculator, you should be able to get something like 4 root of 2. So now that we know the gradient of the normal, okay, so we can try and look for a coordinate at that point, this point here. All right, so what I'm going to do is I'm going to take x, which was given in the question as tan square 2t. So tan square 2 times t. So t is basically 1 over 8, so that's pi over 4. So when you multiply this, and of course if you square this, you're going to get 1 to the square, and that's going to be 1, because tan of pi over 4 is 1. And at the same time, I can find y, and y was given as cos of 2t. So that means cos of 2 times pi over 8, so cos of pi over 4, which is a root of 2 over 2. Right, so now that we've got our coordinate, we can easily find the equation. Equation of the line should be given the form of y is equal to mx plus c. And so we have y1 minus y2 is equal to m into x1 minus x2. So I'm going to be using this. And right away, so y1, which is then y, minus the y coordinate, and the y coordinate is here is root 2 over 2. So root 2 over 2, and then all of that's equal to m, the gradient, which is 4 root of 2. We just found that, into x minus the x, which is now 1. So I have y is equal to 4 root of 2 times x minus 4 root of 2, and minus root of 2 over 2 can go on the other side, becomes plus root of 2 over 2. That's half root of 2. So minus 4 plus half is minus 3.5, which is minus 7 over 2. So what I'm saying is that y is going to be equal to 4 root 2x minus 7 over 2 root of 2. So that turns out to be the equation of the normal. Part B of the question is done. Take care.